Hi everyone, welcome to Vedantu J English. I'm Diksha, your chemistry master teacher, and welcome all the JEE 2027 aspirants. Okay, everybody, let me know in the chat box if you are JEE 2027 aspirants or JEE 2026 aspirants. So this lecture is dedicated to JEE 2027 aspirants who want to have good basic foundations, right? I'm not going to teach any chapter here, but I'm going to teach about the basic things about all the chapters that you're going to study in class 11th and class 12th. And this, ma'am, I am preparing for JEE 2026. Can I watch this lecture? Surely you can watch this lecture. But see that if all the basics that I'm doing you already know or not. If you think that, okay, this is something I don't need to watch, right? You can ignore. If you feel that, yes, these basics are not clear, like which will form ion, which will have +2 charge, which will have +1 charge, all these things, how to balance the equation, right? The base of organic chemistry, why organic chemistry exists, the base of simple atoms and molecules. This is all I'm going to discuss in today's lecture, right? So everybody, very good, very good. Basics, no basics. Okay, so let us start this without wasting any time. But before that, for all the aspirants out there, whether JEE 2026 or JEE 2027, then students, we have a very, very interesting thing for you. That is, in all our Vedantu offline centers, the admissions are open. But in this admission, if you want to get through some scholarship, then we are providing you this Vedantu IV SAT program. The link is in the description. Just click on that so that you register yourself, so that what will happen after this, once you register your marks, right, depending upon your marks, you will get this scholarship, and up to 90% scholarship you can avail here, right? And if you're thinking that, ma'am, I am a dropper, then for the repeaters as well, we have rank improvement guarantee. Your rank will be improved, and also if it is not there, then 100% fees will be refunded, right? Okay, now this is very, very beneficial for all the students who are looking for offline things. And ma'am, where is my offline center? Then you can see here, locate for nearby center near to your house. And if you're thinking that, ma'am, what are the results, what are the JEE results, like you can see for yourself. This is our Karnataka state rank. You can see this here, right? AIR 15, right? That is Daksh, right? You can see that why it is so, because of the quality of education that we provide, right? So now you can see all the other students as well here. You can also be one of them, right? If you actually decide the right path, right mentorship, right guidance at this point, right? It's not only your hard work what is needed, definitely, but the right direction where the hard work should be done, that is also required. And for that, we have our experts, we have our counselors. You can go and meet our teachers and counselors. And I told you about IV SAT scholarship. You can also get 90% scholarship discount, right? Okay, so that is all for all the students who are looking for offline centers, right? Everything is in the description box. You can check that out. Now, students, let us start with chemistry, right? So basic thing is, when you will study in class 11th or 12th, chemistry is divided into 3 parts: physical, inorganic, and organic chemistry. Now, what is physical chemistry? Physical chemistry is mostly related to, like, the reactions that you see, in a battery, the reactions, like it is mostly related to reactions. It's quantitative analysis. Quantitative means how much quantities form, this and that. That is whole related to physical chemistry, right? So in this, what we are going to focus on, mainly theory and numericals. And numericals, usually calculation, numericals is where students get stuck here. Then in organic chemistry, we study the periodic table, right? And we study the different forms of bonds, like you have ionic bond, you have covalent bond, you have on covalent bond, you have a chapter called chemical bonding. On coordinate bond, you have a chapter called coordination chemistry. Rest of the inorganic chemistry is about periodic table, studying S block, P block, D and F block. Then talking about organic chemistry. Organic chemistry is all about carbon and its compounds. Like you must have studied in class 10, there was a chapter called carbon and its compounds. It is the extension of that thing, that we know that carbon forms a lot of compounds, and Out of those compounds, you have different functional groups that you are going to study in your class 12th and your class 11th, right? Okay, now let us see what is the syllabus. You can go through the syllabus here, students. So if you see this here, actually some of the topics here, no, they are in JEE Advanced, some are in JEE Mains, right? If you see, this topic is not in JEE Mains, this topic is also not in JEE Mains, but that is there in JEE Advanced. So if you are preparing for JEE Advanced, solid state also you have to do, surface chemistry also you have to do. But in CBSE board exam, these two chapters are not there. In JEE Mains also it is not there. But in state board exam, in some state boards, the syllabus includes solid state and surface chemistry, right? Depending upon different boards, right? So this is what you have, some basic concepts of chemistry. States of matter is also not there in JEE Mains, right? Then structure of matter, atom, chemical bonding, then chemical thermodynamics, equilibrium, redox reaction. All these are the chapters from class 11. And from class 12th, it's solutions, electrochemistry, and chemical kinetics. That is there in JEE Mains, right? Now, for inorganic chemistry, you will see this chapter is there. This chapter, chemical bonding. Hydrogen is not in JEE Mains. It is in JEE Advanced. This is also not there in JEE Mains, right? Out of this, you will see P block is there in JEE Mains, right? Full P block. But P block is not there in new NCERT. If you see the new NCERT, it is not there in the NCERT, but it is there in the JEE Main syllabus, right? Then DNF block elements, that is also there. Coordination compound is also there. General process of metallurgy is also not there in JEE Mains, but it is there in JEE Advanced, right? So all these things you should be clear about. Most of the organic chemistry is same for JEE Mains and Advanced, except for some little chapters, right? This is JEE Mains, JEE Mains. This is not there in JEE Mains. This is polymers is not there. This is not there. Now everything else you have in your JEE Mains, right? Rest is JEE Advanced. Now you can set up your target, right? What is your target, JEE Mains or JEE Advanced? I would advise you to set up a higher target, right? Like JEE Advanced, right? Why? I have already made a lot of videos, right, on how to cover JEE Main syllabus, how to cover JEE Advanced syllabus. If you want a dedicated roadmap for JEE Advanced for 2027 aspirants, do let me know. I'll surely make a video on that as well, right? So that was the introduction part of chemistry. You should know that what you are actually going to study in the JEE Mains and JEE Advanced. Now, let's talk about some very basic things from your class 9. Everybody, let's be interactive here. I know this is going to be very basic for you, but don't worry. This will be helpful in upcoming, lectures. Now, if you talk about matter, a matter is something that has mass and occupies any space and has matter. So, for example, I talk about me. I am a matter because I have some mass. I am occupying some space, right? If you talk about this air, is that a matter or not? That is also matter because that has some mass. Gases have mass, right? And they also are occupying the air, right? That is why we are saying that they are considered as matter. Now, non-matter is anything that does not have mass and does not occupy any space, right? It is not occupying any space. That is called non-matter, or it is also called antimatter. I don't know if you have ever heard about antimatter. That itself is a very different thing, right? In your NCERT books, it is not there. Nothing is there like antimatter. But beyond your books, right, we have, you can search it on internet as well. It's a very interesting study. You have matter, you take it as plus, right, and antimatter is negative, and they will cancel each other and they will make zero. That is called antimatter, right? So you have non-matter, you have antimatter, that you don't need to get into, right? We only will focus on matter. That means that occupies space and that has mass. Now, if you talk about the one, classify the following as matter and non-matter. If you talk about light, right, that is like occupying space, right? Now, if you talk about love, moon, sun, sun is occupying, moon is also occupying, sun is also occupying, pen, dog, air, sound, then you have energy, then you have fingers. Fingers is also occupying. So that means out of this, few things that can be questionable here. See, love is definitely, it's a feeling, it's not a matter. right? So this is not definitely, this is definitely a matter, this is definitely a matter, right? Air is also a matter. Now the question is about sound fingers, sound, energy and light, right? Sound, energy and light. Let me know in the chat box what you think about that, right? Let's not get into antimatter, no. We'll take some other lecture for antimatter. We'll have a discussion on that, but that is not related to your studies, but we will have a discussion on that someday, right? So now students, you can see that light, if you see, right? Can you tell me why light is not a matter? Anybody in the chat box? Light is made up of photons. Photons are massless, right? That's why it is not occupying any, as such, it does not have any mass, because it does not have mass and it is not occupying any space. Light is not occupying any space here. Like, it's just my eyes who can see light, right? It's not that light is occupying this space, right? It's not like that. Okay, I'll tell you one thing about this, right? Why you can see me, why I can see you, because we all lie in the visible range, right? We are not lying in the infrared range, right? There are some energies that we emit that are in the infrared range that we can't see, right? Okay, that doesn't mean they do not exist. Similarly, light is the opposite of that. Like, you think that you can see light, it is occupying the space. In reality, these photons are massless, right? So they are not occupying any space here. That's why light is not under the category of matter. Love is not, definitely not. What about sound, right? Sound only we can hear, right? That is also made up of radiations which are massless, completely massless. That's why sound is also a non-matter. Energy, if you talk about different forms of energies we have, right? They are not occupying any space here, right? So energy is also massless thing, that is a non-matter here, right? So that is very important for you to understand. Understood, everybody, right? So sound is like vibrations, right? You transmit the vibrations. They are not any matter that is having some mass, right? Energy is also a form, like you have kinetic energy, you have potential energy, internal energy, heat energy, right? This is not occupying, this is not as such a matter here, right? So light, sound, energy, they are non-matters, right? They are not made up of any atoms, right? But if we talk about matter, this is divided into solid, liquid and gases. There are other two states as well, that is plasma and Bose-Einstein, right? So solid, liquid and matter. Solid is that we see everywhere, like I am a solid person, like you can see this atoms, these are solid, right? Liquid is what we drink, water is a liquid, right? And gas is what is in the air, right? That is gas, right? So now talking about solid, liquid and gases, right? How they are defined, how we can understand that this is a solid, why solid looks like a solid, why liquid looks like a liquid, why it is so? Because of the atoms arrangement between them, right? So every matter is made up of very tiny atoms, okay? All the matter are made up of tiny particles like atoms. Now, the arrangement of these atoms will tell you that whether they are solid, liquid or gases. Let's say these have two forces are there. First is force of attraction. That is the attractive force that is binding it together. Other is the repulsive force. That is, repulsive force means the thermal energy, right? Thermal energy means when two atoms are coming together, there is thermal heat energy that is produced, that is repelling them, right? So when you talk about force of attraction, that is the attractive force. That is the attractive force. And when we talk about thermal energy, that is the repulsive force that wants it to stay away from each other. Now, if you talk about in solids, right, force of attraction is very large as compared to thermal energy. That means the atoms are very close to each other, right? In liquids, force of attraction is less as compared to thermal energy. That means the atoms are not very close to each other. But in gases, thermal energy is very high. That means atoms are very far away from each other. That's why gases, we can't just, like, why I can pass my hand out of this gas. but I can't pass my hand out of this board. Why it's not possible? Can I pass my hand out of this board? No, because atoms are very close to each other. But I can pass my hand out of this air. But can I pass my hand out of the liquid? Not as easy as air, but it's not impossible as a wall, right? You will have to swim, you will have to, put in a lot of pressure, force. Only then you can make those particles away from each other, right? So that means it has some intermediate level of force of attraction here, right? So here atoms are very close, here they are intermediate, and here in the gases they are very far away from each other, right? So now let us talk about, it's like, see, plasma we will not talk about here, right? Plasma right now we will not talk about. What is plasma? What is Bose-Einstein? First is gases, particles are very, very far away. In liquid, particles are still close. In solid, particles are like next to each other, like very, tightly very bound to each other, right? Now, let us see the states of matter. If we can see the weight that can be occupied, I think this is visible to you, right? So this is the states of matter. This is weight, space, fixed shape, fixed volume. This you have also studied in class 9th. Okay, just I am recapping this thing, right? So solid is can be weighed, liquid also we can weigh them, gases also we can weigh them, right? The if you talk about occupy space, solid also occupies space, liquid also, and gas also. Fix the shape. See, solid has a fixed shape. It's not like you have an almirah in your room and the next day it will be in some other shape. Today it is a rectangle, tomorrow it will be in square form. It's not like that. Today your house is in rectangle form, tomorrow it will be in the hut form. It's not like that. Ne? That some in summers, because of the sun, it is now melting, the house is melting, but in winters it is like a glacier. It's not like that, right? So solid has a fixed shape, but liquid, they can change the shape, right? If you put it in a big jar, it will take the shape of the jar. If you put it in some small circular ball, it will take the shape of the circular ball, right? So it does not have its own shape. And gases also do not have its own shape, right? Gases also, they can occupy the shape whatever container you put them into, right? Next is fixed volume. Now solids have fixed volume, liquid also have fixed volume, right? Unless until you drink that water, it will have a fixed volume, right? It's not like, yes, vaporization can occur, some of the water can be evaporated, but it's not like you put 1 glass of water in just 2 seconds, you will have half glass, unless and until you drink it, right? So it has a fixed volume, but gases, let's say, okay, so let's say I have this bottle, right? So this is the liquid. Because I have this much water, that's why only this much is being filled, right? Now, if I drink some water, right? Now the volume has decreased. It's not like this much volume will take up the whole beaker. But in gases, it's not like that. You put very less gas, even then it will occupy the full beaker. The volume will be of this beaker. Even if you put 2x of the gas, then also it will occupy the full beaker. Even if you put 3x, 4x, 10x, it will put in this beaker. It will occupy every single space of this beaker. That means, can I say that gases do not have its own volume? Gases do not have its own volume. Can be compressed. These solids we cannot compress. I can't compress this, right, and put it into some different shape. It's not possible for me. Okay, so if I have this, let's say I have this thing here, right? Let's say, anything you can pick out in your room, right? If you try to compress this, it's not possible. Yes, sponges and all we can compress, but because they have holes inside them, right? So we can't compress them. Liquid also, I can't compress the liquid and change its shape or something. It's not possible. I have to put it somewhere, then only I can compress it, right? So it's also not compressible. But gases, we can compress the gases, right? We can put the gases in a very, very small volume also. And that's why this is the process called liquefaction, where gases are compressed They are far away from each other, right? Gases are compressed to that extent. Wait a minute. Wait a minute. Okay. So gases are compressed to that extent that they become liquids. That is called liquefaction of the gases. Right? Clear, everybody? Now let's talk about this plasma state. For plasma state, you don't have to get into that much detail. Just understand that it exists at a very, very high temperature. There is also one more state that is called plasma state, that is at a very, very high temperature, and it is not found usually in our earth naturally, right? It is found in the nature, right? Example, aurora, right? Aurora, this, I know you have seen this filter on Instagram, right? There was 1 or 2 year back, there was this filter that was very famous. Do you remember? But that was just a filter. In reality, aurora does happen, but very rarely, at least I have not seen in real, right? So that does happen, right? And that thing, yes, and that thing is called plasma, right? That thing is called plasma. And there is one more state that is more instant state, that is also in your 11th and 12th, you are never going to use it. Just I am recapping this thing, right? It exists at a very low temperature, right? Plasma exists at a very high temperature, and this exists at a very, very low temperature. Now, let's talk about temperature. Okay, so temperature has 3 units. Acha, tell me one thing. Whenever, what's your body temperature? What's your body temperature? North poles, ma'am. Very good, very good. I know you remember everything from 9th and 10th class. So that's great. That's great. So, if you see this here, temperature, if you talk about the body temperature, right? Body temperature. What is the body temperature? What is the body temperature? Body temperature is 99, right? 99, 97 something it is. Now you have to tell me this 97 is in which units? Is it degree Celsius? Is it Fahrenheit? Is it Kelvin? There are 3 famous units: degree Celsius, Fahrenheit, and there is Kelvin, right? So whenever most of the thermometers, they use Fahrenheit, right? That means this is 97, around 97, 98 Fahrenheit is our body temperature in Fahrenheit, right? It is not in degree Celsius, right? So this is our body temperature. Now that means if I talk about 97 degrees Celsius, that is completely a different thing. 97 degree, 100 degrees Celsius is the boiling point of water. Our body is not boiling. That means we need to have knowledge about units, unit conversions, right? So let's talk about these 3 units, okay? So if I talk about, let's say, we are talking about degree Celsius. Degree Celsius is somewhat here. Fahrenheit, this will be somewhat here. And Kelvin will be somewhat here. Let's see what exactly is this, how to convert this into each other, right? So if you talk about Kelvin and degree Celsius, this is the most famous relation that will be very useful to you when you are doing in 11th and 12th class. Almost every other numerical in physical chemistry, you will use this formula. Almost every other numerical, that Kelvin is equals to degree Celsius plus 273.15. Okay, so when I say 0 degrees Celsius, that is actually 273.15. When I talk about 25 degrees Celsius, that is 298 Kelvin, right? Okay, so you should know that the thing that are mentioned in degree, these two should be on your tips. 25 is 298, this is 273, right? Otherwise also you should know that, let's say 27 degrees Celsius, that is nothing but it is 300 Kelvin. How we are doing this? By adding 273. You can add 0.15 also, you can ignore 0.15 also, but 273 should be on your tips, right? So now next is, if you have to, this is very rarely you will use Fahrenheit and degree Celsius, but still, right, they can ask you these kind of questions, because we, like, they can give you temperature in Fahrenheit and in the question, in most of the question, you will put the temperature in Kelvin, right? So you have to then convert it into degree Celsius, then to Kelvin, right? So 1 degree Celsius is 5 by 9 Fahrenheit minus 32, right? Like you have 0 degree Celsius, you put it here 5 by 9 Fahrenheit minus 32, and you will get your answer in the Fahrenheit. Okay, so this is the formula for conversion of degree Celsius and Fahrenheit, right? Okay. Okay, students. Now let's see if you're able to do this question or not. That is, at which temperature degree Celsius and degree Fahrenheit have same reading? They have the same reading at which temperature? Minus 32, minus 36. See, if you put minus 32 here, if you put minus 32 here, right, that will not have the same reading. Yes. Temperature this. Yes. That means degree Celsius and Fahrenheit should have the same reading. That means they should be equal to each other. When it is equal to each other, when it is equal to, you can put it here C, then you can solve what is the value here, right? Everybody try to solve it yourself only. Yeah, so I'll just solve it here, right? You can put it here. Let's say this is C. I'm putting this also as X. I'm putting this also as X. X minus X is equals to 5 by 9. X minus 32. So that will be 9X. This is 5X minus 32 multiplied by 9. Okay. So that will be 9 minus 5, 6, 7, 8, 9. That is 4X. This is minus 32 multiplied by 9. X is equals to X is equals to, this is 4. Eight. If I put here degree Celsius, if I put 40 and 40 here, wait a minute. It is not coming out to be that. So let's put different values here. I think then it will be possible, right? If I put 40 here, right? If I put 5 by 9, this is minus 40 minus 32, right? If I put that here, then it will be 5. This is 9. This is minus 72, right? Then I can get, yes, then I can get the value minus 40. Yes, then I can get the value 40 here, hai na? Yes. So that means we have to put it minus 40 here, only then we will get the value, right? Okay, so you can put it by using X value also, you can solve it as well. Answer will be at minus 40 degrees Celsius and Fahrenheit will be having the same reading, right? They will be having the same reading. This you must have seen in lower classes as well, right? You can solve it as well. My idea was that you solve it with the help of this formula by putting this as X. By putting this as X, you will get the same value, right? That is 40, right? Or you can just put in the values 40 minus 40. You can solve it there. Then also you will get the same answer here, right? Now, let us see the next one. That is, if you have, let's talk about, that was about temperature. For temperature, that's it what you need to know. After that, beyond that, you don't need to know anything, right? Fahrenheit is also very rarely that they give you that. Now, let's talk about atoms. Now, of atoms, if you talk about atoms, you will study that in structure of atom in detail, right? But in structure of atom, I'll give you just a conclusion part of that, what you have already studied, right? So, in the nucleus, you will have proton and neutrons, right? And electrons are revolving around it. That is your structure of an atom. right? You will study different theories based on that as well. Who discovered electron, who discovered neutron, who discovered proton, right? And what is a nucleus, who discovered nucleus, right? Is this the correct model, or there is more model, that is quantum mechanical model of an atom, that you will study in structure of atom. That is going to be very important thing for you, right? And till now you have studied electronic configuration is KLMN, right? But after that you will study electronic configuration is 1s, 2s, 3s. This kind of electronic configuration you will study, right? But we will study that in detail in structure of atom. But for now, what is important for you to remember, that matter is made up of very small particles called atoms, right? Now these small particles are called atoms, and here inside the nucleus, protons and neutrons are very close to each other. It's like protons and neutrons are in like relation, and this is the third wheel, that is the electron, who is, nobody is asking about electron, but electron is somewhere revolving around them, and black, just revolving around them and focusing that what these two people are doing, right? So that is your full structure. Now here you will also, in your class 11th, you will also study how to calculate the charge of electron, right? So for your knowledge, the charge of electron is minus 1.6 into 10 raised to power minus 19, proton is plus 1.6 into 10 raised to power minus 19, and neutron is 0. Relative charge, we take it as minus 1, plus 1 and 0. And if you talk about mass, mass is 9.1 into 10 raised to power minus, I can also write it here, right? Or don't worry, you will get the PDF. 9.1 into 10 raised to power minus 31. Mass of here is 1.6 into 10 raised to power minus 27. And mass of neutron and proton is approximately same. It is approximately same, but not exactly same, right? If you see the value here, the value is 1.6726. Here it is 1.6749. So that means neutron has, you can see the change, the difference in the value is there, right? The difference, neutron has slightly more mass as compared to, very slightly, which can be easily ignored. That's why we take the mass of neutron and proton as exactly the same only, right? And if you see the approximate relative mass, we can ignore, because this is in 10 raised to power minus 31. Electron is 10 raised to power minus 31. And neutron and proton is 10 raised to power minus 27. So that's why we also ignore the mass of electron, because it is so small, it is so negligible, right? That is the reason you see approximate mass is 0, proton it is 1, neutron also it is 1. Now let's see the representation here, right? Now if you see this here, first thing is, for representation you need to know what is atomic number, that is defined by Z. That tells you number of protons present in the nucleus of an atom, right? Now, if you talk about hydrogen, hydrogen has 1 proton and 1 electron, right? And it is the only element that does not have any neutron here, right? That's why deuterium will have 1 proton, 1 electron plus 1 neutron. These are the isotopes, right? We will talk about isotopes, don't worry. But till now, just remember one thing, that hydrogen is the only element that does not have any neutrons, right? It has 1 proton and 1 electron, that's it. Now, talking about the mass number, as I told you that electron mass is almost negligible, right? Now we know that because electron mass is negligible, that's why on calculating the mass number, we only take neutron and proton. We only consider neutron plus proton. That's why mass number is equals to neutron plus proton. That is your mass number, right? And if you represent this, you have to memorize the atomic number and mass number. Now, if you talk about the atomic number, that is the protons, and mass number, that is the neutron. This is proton, this is neutron plus proton, right? Now, if you have to memorize, right, this 120 element, first 20 elements should be on your tips before starting class 11th only. Before starting class 11th, please, plus first 20 elements should be on your tips. Rest of when you will, start studying, right, it will eventually be in your head. But first 20 elements should be on your tips from now onwards only. So that's why I'm giving you it here. So you can see that hydrogen is 1, this is mass. hydrogen, helium, this is sorry, atomic number, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium, 1 to 20. Mass, now understand, mass is usually doubled, okay? Here the mass is not doubled. Can you tell me why? Because hydrogen does not have any neutrons. That's why number of neutrons is not added. Otherwise, this is also doubled. This is also doubled. See, one thing is either it can be double or it will be double plus 1. Mostly you will see this. This is double. This is double plus 1. This is double plus 1. This is double plus 1. This is double, double, double plus 1, right? Double, right? Now here it is double plus 1, right? Double, here it is double plus 1, right? It is double, right? This one is double, this is also double plus 1, this is also doubled. Chlorine mass is, I'll tell you why chlorine mass is in fraction. Don't worry, we'll talk about this in isotopes. When we will study about isotopes, we will study that why the chlorine has atomic mass in fraction. Why? What is the reason behind that? Right? If you talk about argon here, that is double 18 into 2 plus it is plus 2 it is, right? Plus 4 it is. So it is not exactly this. Right, so that is 40, right? This is also not exactly, this is 39, this is double, right? So you can see this is double, right? Some of this, I am not saying this is applicable everywhere. Out of first 20, most of it is applicable. Now, you should remember all the masses. See, when you cross a certain, when you practice a lot, these things will be on your tips only. Right, these things you don't have to memorize them again and again and again. These things will be on your tips. Right. For example, someone asks you mass of magnesium 24, mass of aluminium that is 27, mass of sodium 23. That will be on your tips. Mass of oxygen 16, mass of nitrogen 14. You don't even have to multiply or add. But for the starting, do it this way. But as you practice questions, that will be on your tips automatically. Right? Okay, take a screenshot of this particular page. That will be very important for you. Right? Next is beta representation. If you talk about the representation, let's say this is element X, this is A and this is Z. That is the representation. So if I want to represent hydrogen, one isotope, it will be 1H1. This is the proton, this is the mass number. Right? Let's say, let's represent nitrogen. Nitrogen proton is 7, mass number is 14. That's how you represent the atoms, right? Okay. Now, one thing to understand here, A is the mass number. That is neutron plus proton. Z is the atomic number, right? That is protons. And this is also equal to electron in neutral atom. See, because protons are inside the nucleus, we can't take protons very easily, right? But if you talk about electrons, right, they are revolving, so we can take them out, right? Now, if you have a neutral atom, then protons and electrons are equal. But if you have an ion, you take out electron or you give electron, then protons and electrons are not equal. And in that case, that is only the protons, not the electrons. So that should be clear in your mind. Now, what is neutron? A minus Z means N plus V minus P. That is your number of neutrons, right? Okay. This representation also you should know, because that also you're going to apply in your upcoming sessions, right? If you talk about this, how many protons and neutrons are present in the following nuclei? How many neutrons? If you talk about this, protons and neutrons, proton is Z, neutron is A minus Z. Proton will be 6, neutrons will be 6, because that will be 12 minus 6, that is 6. In this case, proton will be 26 and neutrons will be 56 minus 26, that is 30. Okay? Yes, everybody? Representation of an atom. Atom, beta, atom. Trick, ma'am, for mass number. Beta, mass number tricks, na, I usually don't believe in tricks, वैसे, right? because tricks are needed where you actually need them, right? Trust me, mass number, you don't need any trick. Just try to write it again and again. That will be in your head, right? Now, if you ask me any mass number, that is in my head right now. Why? Because we are solving so many questions, right? When you solve it again and again, you don't even need to cram it, right? That's why I'm not giving you any trick. I've just given you table so that you go through that on daily basis, right? Till you remember that. Now, students, next is let's talk about isotopes. Okay, can you tell me what is the meaning of iso? Anybody in the chat box, what is the meaning of iso? Hello, Sugandhana. Hello, Abhijit. Hi. Okay, chal. Now, students, tell me what is isotope, right? This you must have studied in your 9th and 10th classes. Iso means same, right? Now, isotopes is which have same atomic number, but the mass number is different, right? So, atomic number is same, but mass number is different. Mass number is different. That means protons are same, but neutron plus proton are different. That means neutrons will be different here. That's why mass number is different, right? So in this case, protons are same and neutrons are different. Example, like you have hydrogen 1 isotope, which is having 1 atomic number, mass number is also 1. Deuterium, that is having atomic number 1, mass number is 2. Tritium, that is having 3 mass number, atomic number is 1 only. Why? Reason is because here you have no neutron. Here you have 1 neutron. Here you have 2 neutron. Here you have 1 proton. Proton is 1. Proton is 1. So proton is same, but neutrons are different. That's why the mass number is different. Same with carbon isotope. You have 12, 13, 14. Oxygen, you have 16, 18 isotope. So these are the isotopes of the famous compounds, right? Now, if you talk about what are isotones, can you see isotones? N. So, isotones are nucleosides that have same number of neutrons but different number of protons. Can you see the here what you had? Same number of protons, different number of neutrons. This is opposite. Here you have same number of neutrons. Neutrons are same. Neutrons are same. Neutron same means what? A minus Z is the same. But protons are different. Protons are different here. Right? A minus Z is same, but protons, that means Z is going to be different. Okay? Z is going to be different, but A minus Z is going to be same. Is that clear to everybody? Same number. By this you can see ons, N. That means they are talking about neutrons, right? By this you can remember neutrons. What are isobars? They are also opposite of isotopes. What is isotopes? Isotope is same atomic number, different atomic mass. In this case, you will have same atomic mass. Same atomic mass means A will be same. What is different here? Different atomic number. Same atomic mass, different atomic number. Can you see very slight difference? Here A minus Z is same. Here A is same. Right? Here A is same. Here A minus Z is same. Right? And Z is always different in this case as well, in this case as well. But in case of isotopes, Z is same, but atomic number, or you can say not atomic number, mass number, or you can say neutrons, they are different. Okay? Understood everybody? What is the definition of atomic number, mass number? I know right now you are in this position. Is it? Are you in this position right now? Everybody. In which class shall we get taught of this? In 11th or 12th? This is in both, right? Because mostly you will teach this in class 11th, right? In structure of atom, you will see this. In periodic properties also, they can teach you this, right? Most of it, they will teach you this in structure of atom, right? But this will be useful throughout chemistry, right? Throughout chemistry means throughout chemistry you will use isotopes, isobars. These are general terms, right? Okay. Can neutrons be equal to protons in every element? No, 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 no. There is nothing, no standard fact that neutron is equals to proton. It may be, it may not be. See, basically, when let's talk about nitrogen. Nitrogen atomic number is 7, atomic mass is 14. In this case, neutron is equals to proton. Because proton is also, neutron is 7 and proton is also 7. That's why you will see A, mass number is coming out to be 14. So only when atomic number, when you multiply atomic number by 2, you get mass number. In that case, neutron and protons are equal. Otherwise, they are not equal. Got it? Otherwise, they are not equal. Excellent. All the 9th students who are here, right? Great that you are, right now only you are studying about this chemistry, right? That's so great to see 9th standard students also here, right? Because if right now you are studying the basics from YouTube, right? That means you are very, very serious, right? So, yes. Now, let us see a simple trick to understand, to make this simple thing here. Iso always means same. N is number of neutrons are same, and here you can say A, that means mass number is same. Here you can see P, that means number of protons are same, right? That's how you can remember this, right? Iso means same. Now what is same here? In this you have N, that means neutrons are same. Iso B, A means mass number is same. Here you have P, that means number of protons are same. Clear everybody? What is different? Same number of neutrons, same number mass number, same number of protons. That is your isobars, isotopes, and isotones, right? Now, what is the isoelectronic species? Isoelectronic means which has same number of electrons, right? So let's say you have O2 negative and F negative, right? Can you tell me what are the number of electrons here? See, oxygen has a atomic number is 8, right? Now, that means 8 electrons will be there in a neutral oxygen atom, right? See, in a neutral atom, number of protons and neutrons are same, right? So, for an oxygen atom, right, if you talk about an oxygen atom, it will have 8 electrons. Fluorine atom will have 9 electrons. But if you talk about oxygen O2 negative, that means you are adding 2 electrons here. You are gaining 2 electrons. You are adding 2 electrons to oxygen, it will become 10. Here it is what? 9. You are adding 1 electron, it will become 10. Right? Or let's say you are talking about Na positive. Let's say you're talking about Na positive, you're talking about Mg2 positive. If you see this here, sodium is on the 11th position. 11 is the atomic number. That means they are the number of electrons in the neutral atom. Plus means it is a cation. Whenever we add plus there, that means it has lost 1 or 2 electrons to become this cation. So it has lost 1 electron. That means it is 10. Mg2 positive also, it is atomic number is 12. You are losing 2 electron and it is 10 electrons. So that means all of these are isoelectronic species, right? Okay, all of these are, yes. Al3 positive is also there. Al3 positive, if you see, Al3 positive beta, if you see, that is also going to be 10 only. This is 12 minus 2 is equals to 10. Aluminium is 13 minus 3 is equals to 10. Right? Okay. You can also put here N3, nitrogen 3 negative, nitrogen 3 negative, nitrogen 3 negative. Nitrogen is in the neutral, it has 7 proton, means same is the number of electron. Plus 3, it is gaining, that will be 10. So these are which have same number of electrons. These are called isoelectronic species. Okay. Yes, students. Mole concept as such, no. But in your JEE exam, they ask a direct question from isoelectronic species. That we will study in periodic property also. Structure of atom also you will study this isoelectronic species, right? Mole concept as such it is not applied, but this they can definitely put some concept of isoelectronic and ask you that question. Now, which of the following are isoelectronic species? Can you tell me same number of electrons you need to have? If you see, this is nitrogen is 7 plus hydrogen is 4 minus 1, that is 10. This is 7 plus 2 plus 1, that is 10. This is 6 plus 3 minus 1. Positive means subtract 1, negative means add 1, right? So it is 6, 7, 8. This is nitrogen is 7 plus 3, that is 10. So we can say 1, 3 and 4. 1, 3 and 4. 1, 3 and 4 are your isoelectronic species which has same number of electrons. Okay, which have same number of electrons here. In, when you will start studying structure of atom, there are other iso species also like isosters, isodiaphers that we are going to talk about, right? But that I'll teach you when we will cover structure of atom. In that process, I'll teach you those. Okay? Okay. Till here, students, any problem? Till here, any problems? Let's see this question. Consider the atoms, oxygen, this and this and this and this. Answer the following. Which of the following are isobars? Everybody, let's see who is able to answer this. Okay. Previous. Have I not checked? Okay, I'll check that. Don't worry, I'll check that. Okay, I'll check that. So let us see, students. Consider the atoms oxygen 16, oxygen 18, fluorine 16, neon 18. Isobars. Bars means A will be same. Means mass number is going to same. Mass number should be same. Mass number is same in this and this. But proton should be different. Protons are different in this case. Mass number is same. So can I say isobars are oxygen 18, fluorine 18 and neon 18. These are the isobars of each other, right? If you talk about isotopes, isotopes means mass number is different, but the base, that means atomic number is same. Atomic number is same in this case, right? So we can say oxygen 16 and oxygen 18. This one pair is isotope and this one pair is also isotope. That is neon 18 and neon 20. Because a single atom that is represented by a single neon can have only like same number of protons, and no matter how many different if you change the protons, you will change the atom only. If atom is same, that means protons is also same, right? Okay. Do isobars have same or different physical properties? Isobars, guys, isobars have same or different physical properties? Everybody let me know in the chat box. Isobars have same or different properties, is it? Everybody, let's talk about that. Isobars have same or different properties. Isobars means we are talking about when mass number is same, but protons are different, right? So physical property, that means atom has changed only, that means physical properties also will be different. Then which have the same number of neutrons? Neutron means A minus Z should be same. So if we talk about here, Z is 8, Z is 8, 9, it is 10, it is 10. A minus Z here is 10, A minus Z here is 8, A minus Z here is 8, A minus Z here is 10, A minus Z here is 8. So that's saying which has same number of neutrons. Same number of neutrons are there in oxygen 16, then neon 18, then fluorine 18. These have same number of neutrons. And oxygen 18 and what is 10? 10 is there, 10 is also there. And neon 20, they have same number of neutrons. Okay? Yes, everybody? Right, everybody? Okay. Next is, which atoms have same number of valence electrons? Valence electrons. Anybody in the chat box, what is the same number of valence electrons? Valence electron is the outermost electrons, right? Outermost electrons. This I would like to skip for now, because for this you need to know the electronic configuration, right? That I'll teach you in I'll teach you that, don't worry. In structure of atom, I'll teach you valency, valence electrons, don't worry about that. Right? Valence electron means the outermost electron should be same. For that, you should know the electronic configuration that you are going to study. Right? Okay. So, I am just going to erase this. Right? Okay. Now, let's talk about this. Acha, one thing you should know, that what is valency and what is valence electrons. What is valence electrons? This I'll teach you once I teach you cation and anions. There only I'll teach you that. Okay. Now let's talk about a molecule. What is a molecule? A molecule is a group of atoms that are connected via some bond. There is some chemical bond. Either there is exchange of electron, transfer of electron, sharing of electron, or completely, like you can say, donation of electron is there. That is called a bond, right? In that chemical bond, when atoms are grouped together, that forms a molecule, and that is also called a compound, right? Okay, when so many of these molecules of combine together, that is called a compound, right? Now let's talk about atomicity. What is atomicity? You'll always see diatomic, polyatomic, monoatomic. Monoatomic means atomicity is 1. Diatomic means atomicity is 2. Atomicity is the number of atoms that are combining to form a molecule. Like you have H2, you have O2, you have N2. All these have atomicity 2 because 2 atoms are combining to form one molecule. If you talk about O3, that is having atomicity 3. If you talk about P4, atomicity is 4. S8, atomicity is 8. That is about the atomicity. If you talk about H2O, atomicity is 3 because 2 hydrogens and 1 oxygen atom is there. Okay, that is defining you the atomicity. Right, everybody? Okay. Abhishek will talk about that. You can just leave your comment in the comment section. Right? Okay, okay. GXDL. I'll see that. Okay, I'll see that. Okay? Yes. Now, let's see the number of protons present in COR. Can you tell me the number of protons present in CO? This is CO, right? Carbon has how many protons and oxygen has how many protons, students? Carbon has how many protons? Hydrogen, helium, lithium, beryllium, boron, carbon. 6. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen. That is 8. So how many it is? 14. Right? 14 electrons and 14 protons it has. So answer will be 14 is the correct answer. Right? Okay? Yes? Now let us see the next one. An atom, or now what are ions? Okay, let's talk about ions. Ions are when you have an atom or you have a molecule, but you give it some electron or you take away the electron, that leads to the formation of an ion. So ions are of 2 types. One is cation, one is anion. Cation is when you take out the electron. That means when it is positively charged ions. When you lose the electron, cation is formed by losing the electron. Losing the electron, you have the formation of the cation. And when we talk about anion, it is after gaining the electron. That's why it has a negative charge. Why? Because you're giving more electrons to it. So that is called an anion. Right? Now let's talk about this. How many protons, neutrons and electrons are present in O2 negative? See beta, oxygen is having atomic number 8. Atomic number means Z is 8. That means it is the number of protons. That means it is the number of protons that you have. right? Electrons are also same in oxygen, that is 8, but here if you talk about O2 negative, protons will be 8 only, but electrons will be 8 plus 2 because it has gained 2 electrons, that is 10 electrons. Right, this is what we have discussed in isoelectronic species. And neutrons is what? Neutrons will be mass number minus this. So number of neutrons, if you want to calculate here, here they have not mentioned anything. So I'll take it that they are talking about most abundant oxygen isotope, that is having 16 mass. And proton is 8. So neutron will also be 8. Right? Okay. Most abundant oxygen is oxygen 16 that we are inhaling. Ma'am, how is chemical bonding chapter with the, and what precautions we should keep in mind while studying it, like focus more the theory of questions? Sandy, chemical bonding, I'll tell you that. Don't worry. We are going to talk about that. Chemical bonding chapter is more of when atoms are combining to form bonds. First, you will talk about different theories of bond formation, why atoms need to form molecules. All of this is there in chemical bonding. And it is a very scoring chapter, You should know every single detail of chemical bonding. In your class 11, periodicity is a basic chapter. It's not a very scoring chapter in JEE. But without periodicity, you won't be able to understand full block chemistry, right? But chemical bonding, directly the questions are asked from chemical bonding. Okay? Yes. Now, let us see the next. That is valency and valence electron. Okay, guys? Let's see valency and valence electrons. Okay? Let us see valency and valence electrons. Yes. Valency is when you talk about valency, it is the let's take an example. Okay, valency is number of electrons gained or lost. That is called valency, and valence electron is the electron that is there in the outermost shell. So now I'll tell you something which is you will study in your higher classes, right? In chemical bonding you are talking about, there you will study about octet rule. That is going to tell you what is in detail. We will study about valency and valence electron there. Let's take an example here. Let's see, I'm just writing this here. You don't need to worry what I am writing here if you have no idea about structure of atom, right? Okay, don't worry what I am writing here. This is very simple. We are going to study this in structure of atom. Within seconds, you will be able to understand electronic configuration. Let's say I'm talking about 1s2, 2s2, 2p4, right? So this number here, there's a proper way of writing this 1s2, 2s2, 2p, 3s, 3p, right? That you will learn in structure of atom. Now what you understand that this 1, this 2, that is representing the shells. This is in one shell, this is in the other shell. And the number of electrons in the outermost shell is called the valence electron. Okay, the electron in the outermost shell of an atom which takes part in the chemical reaction. So here you have 6 electrons here, right? So here valence electrons are going to be 6, right? Here the valence electrons are going to be 6. But now in chemical bonding you will study that you must have studied this in class 9th also, I think, in atoms and molecules. But there we used to do KLMN. But now we are going to forget about KLMN. We are going to do this way electronic configuration, right? If you see this, we know that octet rule is there. That means in outermost shell, number of electrons should be 8. Here the number of electrons are 6. So what it should do? It should be 2s2, 2p6. That means for that, it will gain 2 electron and it will become 1s2, 2s2, 2p6, right? That means now the octet is complete. That means it has gained 2 electrons. So its valency is 2, right? Suppose, understood now? Now it has gained 2 electron. If someone loses 2 electron, its valency is 2. If someone gains 1 electron, its valency is 1. Valency is how many electron you gain or lose to become stable. To become stable. Okay, this all you are going to study in chemical bonding. Okay, everybody, right? Okay, students. Which part of chemistry do you teach? I teach every part of chemistry. That's why with full confidence I can say that it is interrelated to each other. Right? So this whole you will study in chemical bonding in detail, because in chemical bonding now there will be reasons why chemical bond formation is there. And one of the reason I have already given you, to gain stability, to make octet rule, right? You will study about octet rule. Oct means 8. That means the outermost shell has 8 electrons. Now students usually get confused in valency and valence electron. Valence electron is the number of outermost electron. Valency is to be stable, how many electron it needs to gain or lose, right? This you don't have to understand, ma'am, why this is the electronic configuration. Just understand one thing. It's like you are eating something, right? You are eating something. Now, how much is already there in your plate? Let's say you have one chapati and you can say one bowl of rice is there in your plate, and one bowl of dal is there in your plate. Sambar is there in your plate. So that you can say that is what you have. That is your valence electron. If you are more hungry, then you need one more plate of rice, right? That is your valency. How much more you need to be stable, to be happy. Got it? Okay? Easiest way I can tell you, just relate it with your real life. You have a plate, you have one bowl of dal, you have one bowl of rice, right? That is what your mom has given you already. You are not happy with it. That is the valence electrons. But after that, you would want more. That is the valency, right? The amount that you have gained or lost. Then let's say it's not tasty. You will say, ma'am, I don't want this. I just take this rice. I don't want to eat it. Right? That is the valency. Okay, everybody? Everybody clear, no? Clear, everybody, what is valency and valence electrons? Now, as I told you that every atom wants to lose or gain electrons because it wants to be in the stable state, right? That we will study in chemical bonding, where it will lose, where it will gain the electrons. But now, what is important for you to remember the valencies, how much amount it is gained. So, ammonium ion, it all has valency 1. They would want to lose 1 electron each. Copper would want to lose 1 electron. Hydrogen want to lose 1 electron. Lithium, then mercury, that is in mercurous, potassium, silver, sodium. And I think this you must have heard about. There is one thing called cupric and one thing called cuprous. There is one thing called ferric and one thing called ferrous. There is one thing called mercurous and there is mercuric. Have you seen this in the lower classes, right? See, whenever we talk about valency, lower valency, remember that the lower valency is OUS, higher valency is IC. Let's say in ferric, right? Lower valency is +2, it is ferrous. Higher valency is +3, it is ferric. In copper, lower valency is +1, that is cuprous. Higher valency is +2, that is cupric. In mercury, lower valency is +1, higher valency is +2, that is mercuric. Got it, everybody? What is? Yes, very good. When you have higher oxidation state, that is called IC. Lower oxidation state is OUS. That is in different ways. Mercuric, mercurous. You have cupric, cuprous, ferric, ferrous. Right? That this is what you will see in your upcoming classes. Right? Very good, very good, very good. Now, if you see potassium has +1, silver has +1, sodium has +1. These all are monovalent species. Right? Divalent are like barium 2 positive, beryllium 2 positive, cadmium 2 positive, calcium, chromium, right? 2 positive, it is in chromous, right? Because chromium also exists in +3 state. If you see, chromium will also exist in plus 3 state, but here its name is IC because higher oxidation state is IC. Here this is the lower oxidation state, so that is called chromous, right? Okay. Then cobalt plus 2 state, copper, cupric, because copper, the lower oxidation state is +1. Lower oxidation state is +1, so it is Cu positive. Higher oxidation state is +2, so it is Cu2 positive. Two oxidation state, the lower one is OUS, higher is IC. Okay. Iron, beta, it has two states, +2 and +3. Iron in +2 state is called ferrous. Iron in +3 state will be called ferric. Okay, +3 state will be called ferric. When you have two states, now this is how you do it. Lead has only one state, +2. Magnesium +2. Manganese +2. Manganese has a lot of states, but there is no specific name given to it. Mercury, Hg2 positive. Now, if you see this here, this was mercurous. This is mercury 2 positive, right? Mercury, this will be mercuric. Okay. Nickel is 2 positive, strontium is 2 positive, sulfur 2 positive, tin, that is in +2 state, it is tannous, that is +2. Titanium is 2 positive, right? Now, if you see tin in +4 state, it is called ic, stannic. Why? Because this is the higher oxidation state. This is the higher oxidation state. Same beta, you can see trivalent species like aluminium, bismuth, boron, cobalt. This einsteinium you don't need to do. Gold, all these are +3 state also they show. Carbon, lead also show you +4 state. Molybdenum, silicon, all these tin are showing you +4 state. They are tetravalent. The valency is 4. The valency is 3. Here the valency is 2. Here the valency was 1. Okay. Clear beta? What is valency? Everybody, that is clear to all of you or not? Clear to everybody? Clear to everybody? This you don't need to do now. Okay? This you can ignore for now, right? Because that we will study. Don't worry, in periodic properties we will study about that. Now let's talk about periodic table. Your full block chemistry is based on this. Okay? Tell me if you want me to take up a lecture which is only dedicated to block chemistry. That means I am going to, what happens in periodic table now? While teaching you the lecture, right? We can teach you that this is the concept, this is that. But how to learn the periodic table, how to draw the periodic table, I can give you some basics here. But let me know in the chat box if you want me to take up a dedicated lecture on the periodic table, right? You can also write it in the comment section if you want me to take up dedicated lecture on the periodic table, where full lecture I'll only talk about how to learn this, everything I'll talk about, right? For now, what we can teach you, right? For now, what you can understand, that this thing is called S block, this thing is called D block, this thing is called D block, this thing is called F block, this thing is called F block, right? And this thing is called P block, and this thing is called P block, right? Now, these are the metals, and as you go here, you will transition from metals to non-metals, right? And this is called S block element, this is called D block elements, and F block elements are starting from after lanthanum, you have lanthanoids, that is F block element. After actinium, you have actinoids, that is F block element, actinoids, right? Now, students, there is dedicated chapter for all of this. S block, you have like a chapter in JEE Advanced, but in JEE Mains, it used to be there, but now it's not there in JEE Mains. D and F block, you have a dedicated chapter in class 12. And P block, you have half chapter in class 11, half in class 12, right? But in your JEE Mains, you have the P block in detail, right? So you will study about this in detail. That's why I'm saying that if you don't know about periodic table, you don't know how to draw periodic table, you will end up wasting full block chemistry. Why? Because even if you know the concept, you don't know which element is lying where. What is the atomic number? You don't remember the atomic numbers. You will end up ruining your block chemistry. right? Okay, so that's why block chemistry, to understand that this periodic table should be on your tips. Okay, this, so let's not do this here, right? Okay, let me know in the comment section if you want me to take up a full lecture on periodic table. Now let's talk about chemical bonding, right? Chemical, because I can't teach you periodic table in 10 minutes. It's not possible, right? It's not practical, right? I can only teach you this much, that this is S, P and D block, right? In detail, I have to take up a lecture, right? Now, let's talk about chemical bonding. In chemical bonding, you are going to talk about bonds, right? Bonds, different kinds of bonds. You will talk about ionic bond, you will talk about what is covalent bond, what is coordinate bond. So guys, three things are there. Firstly, let us talk about covalent bond. Okay, covalent bond is formed by sharing of the electron, right? Acha, before this you need to tell me one thing. What is the difference between a negative charge and a lone pair? Okay. See, a negative charge is, what if you have this A and B? This is also A and B, right? In this A and B bond, what if this A atom is from A? This pink kind of atom is from A, or electron. This pink electron is from A. This blue electron is from B. In this case, both the electrons are of A. Now, what if in this bond one electron is of A, one electron is of B? In this case, both the electrons are of A. Now, how this is, so that I'll tell you, that is related to bond only. First, you understand this thing, that when it takes out the electron, this will become A negative. But here, when it takes out the electron, it will become A lone pair. So, when you talk about a lone pair, whenever you talk about a lone pair and a negative charge, both have two electrons. But in case of negative charge, both the electrons are not of the atom, right? Both the electrons are not of the same atom. This one electron it has taken, right, from B, right? That's why it is negative. Whenever someone borrows, whenever someone takes out money from you, right, it gives them a negative aura because they are forcefully taking money from you. So it has forcefully taken money from B, right? That's why it is having negative charge. But here, why it does not have a negative charge? Why it is neutral? Because both the electrons were of A only. It's just that it has taken out those electrons. Is that clear? What is the difference between negative charge and lone pair? Now you will ask me, ma'am, how it can have two different electrons? One is of A, one is of B, but here both the electrons are of A. The answer lies in the covalent and coordinate bond, right? So students, see this thing here. When I talk about a covalent bond, here what will happen? A will be like, and this is B. A will be like, I have one electron, but I also need to have one more electron. B is also like, I also have one electron, but I also need to have one more electron, right? It's like you and your friend, but here what happened, that you have bought pizza and your friend has bought burger. Now you want both. You are like, okay, we can do one thing. You can give me one slice of pizza, I'll give you one bite of my burger, right? So now you are sharing the electrons. That means you are sharing one little pizza, your friend is sharing one little burger, so that you can have a taste of both, right? So this is what they have done here. They have decided that we will make a bond. You can take my electron, I can take your electron. They are not completely transferring the electron, they are sharing the electron. A also needs one electron, B also needs one electron. So they both decided that we will share those two electrons with each other, so that we both are happy. Okay, that is called covalent bond. Ionic bond is that this is A be like I have one extra electron, and B be like I don't have extra electron. This is A and this is B. A be like I have one extra electron, B be like, I need that extra electron. Now A is like, excess of electron it has. A has excess of electron and B has need of electron. Need of electron. So now what will happen? Complete transfer of electrons, right? A will give its electron here. A will itself, because it is losing electron, it will become positive. B, because it is gaining electron, it will become negative. That is complete transfer of electron, right? That is complete transfer of electron from A to B, right? This is called ionic bond. Now, covalent bond, coordinate bond is something I know that students are like totally confused about. Ma'am, what is this coordinate bond? So understand one thing, students. Whenever we talk about a coordinate bond, what we talk about, that a coordinate bond is something when, let's say, this is A and this is B. Okay, A is having 2 electrons, right? Now A be like, I have 2 electrons, buddy, right? B is like, I don't have anything. It's like you bought pizza, you only bought burger. You bought pizza, you only bought burger, your friend bought nothing, right? Now, in case of ionic bond, what was happening? Transfer, that I'll give you my pizza, I'll give you my burger, you take, I don't want to have anything, right? That is called ionic bond. But now, A has both pizza and burger and B has nothing. He has bought nothing for lunch. Now, what you will do? You also want to eat. You also want to eat. Now, you are sharing with someone who has nothing. Covalent bond is sharing with someone where you have advantage. Coordinate bond is sharing with someone when you have nothing in return they can give you. So here, it is not transferring. It is just sharing the electron with B. A is also utilizing those 2 electrons. B is also utilizing those 2 electrons, but these 2 electrons are of A only. So answer will be A and B are forming a bond where both the electrons are of A only. Got it? That is called coordinate bond. Okay, understood, guys? That is called coordinate bond. Is that clear to everybody? That is called coordinate bond. Right? Okay, students. Is that clear? What is coordinate? What is coordinate bond? What is ionic bond? What is covalent bond? This is like A and B you have. This is A and B you have. This is A and B you have. Right? So, if it is complete transfer of electron, it is losing, it is gaining, that is ionic. If both the electrons are of one atom only, that is called coordinate. If one electron is of A, other electron is of B, that is called covalent. So this is called covalent. This is called coordinate, right? This is called ionic. That's why when you see this, when you saw this thing, when from a coordinate bond it is taking both the electron, then there is formation of lone pair. But when from covalent bond it is taking the electron, there is formation of this A negative. Got it? Right? Okay. Yes. Now, let's see which of the following occurs during the formation of coordinate bond. Electron transfer, electron donation, electron sharing. What happens in coordinate bond? Sharing, complete sharing does not happen. There is donation of electron, right? So electron is donated to someone who has nothing, right? Electron is donated to someone who has nothing, right? Okay. Okay, students. Now let's talk about chemical formula of compounds, right? So let's talk about this formula. Let's say you have Al3 positive and you have SO4 2 negative. Now this concept you have studied in class 9. That will be very useful in your class 11th and 12th. Throughout chemistry, this will be useful. Now what we do cross multiplication. Aluminium, this thing will go here, this thing will go here. That means it will be Al2 SO4. This 3 will come to this side. This is your formation of one compound, right? Let's talk about others as well. Let's say you have Mg2 positive and you have CO3 2 negative. right? Now, because this is also 2, this is also 2, what will happen? This is Mg2 CO3, this is 2. 2 will cancel, it will be MgCO3, right? Okay, let's talk about others also. Let's say you have let's say you have Na, right? You have NH4. Let's say you have NH4 positive, you have PO4 3 negative. All of this I have already given you chart, from there you can remember this, right? So now here this is 1, so it will be NH4, this is 3, so it will be thrice, this is PO4 and this is 1, so that is going to be your ammonium phosphate. Okay, so how to form the formula? Just cross multiply it and you will get your formula. Okay students, just cross multiply and you will get your formulas. Right, everybody? Any other formula you want me to make? Right, let's make one more formula. Let's talk about, let's say you have HCO3 negative and this is your Ca2 positive. Right, now what you can do? This will be Ca, this will be HCO3. This is 2 here, so it will be 2 here. This is 1 here, so it will be 1 here. This is calcium bicarbonate because this is a bicarbonate ion. This is the carbonate ion. If they ask you to make the formula, they will not ask you to make the formula. In fact, in class 11th and 12th, they don't ask to make the formula. This is the general knowledge that you should know, right? Let's say you have Na positive and you have HCO3 negative. Tell me, not this, you have CO3 2 negative. What is the formula that will be formed here? Everybody, what is the formula that will be formed here? Right? What is the formula that will be formed here, students? You have Na positive, you have CO3 2 negative. These things you might feel that, ma'am, is this even required? If you don't know this, trust me, class 11th and 12th chemistry, if you ask, ma'am, which chapter they use this? Everywhere in chemistry. Throughout chemistry, you know, chemical formulas, compounds will be there throughout the chemistry. If you don't know this thing, you won't be able to like have even like, it's like cramming question you can answer, but the conceptual question not possible. Chemistry only you will be confused, right? Yes. So here it is Na, right? This is 2 and this is CO3, this is 1. Okay, so it will be sodium carbonate. Okay, yes, everybody? Which one? Which hypothetical? Ma'am, hypothetical, please, one question. Which, any hypothetical you asked, na? Which hypothetical you are asking me to do? Which hypothetical you are asking me to do? Okay, now let's talk about balancing of equation. This also you have studied in chemical reactions, right? One thing is in redox reactions, you will see balancing of equation in a more, I would say, specified manner. There is proper methods to do balancing, right? But if you see, it's not like balancing of equation, you will always follow those two. There are two methods that you will study in your class 11th, but that will be in the ionic form, that when you have really complicated equations, right? But it's not always you have to apply those two steps, those two methods, right? The one that you have learned in class 10th, that will be useful in your entire chemistry, because in physical chemistry also sometimes they give you the reaction, it is not balanced, you have to balance. In mole concept, the balancing is required, right? In mole concept, you don't know how to balance the equation. Mole concept you can't apply there, right? So mole concept balancing is required. Throughout physical chemistry, whenever a reaction is there, you have to balance it, right? In inorganic chemistry, balancing is not that required. In organic chemistry also, it is not that required. But in physical chemistry, it is required to the maximum extent, right? Now, if you see it, you have P4 O10H2O and this thing. Here, what you can do first is, you should be able to, firstly, you can just balance phosphorus. It says hit and trial method, okay? Balance phosphorus, this is phosphorus is 4. It is also phosphorus is 4. Here hydrogen will be 2. Here hydrogen is 4 into 3, 4, 3, 12. So this is, you have to multiply this by 6, right? Now hydrogen will be what? 6 into 2, 12. Here hydrogen is 4 into 3, 12. Okay. Now oxygen is what? Here oxygen is 10 plus 6, 16. Here oxygen is 4, 4, 16. It is balanced, right? So easily, what is the hit and trial method that you can use? You use that, right? There is no specific way. Specific way is that firstly you should balance oxygen, right? Then you should balance hydrogen, that you can do, right? But otherwise there is no specific way. It is just complete hit and trial method, right? Just complete hit and trial method that you can do. Now here you have aluminium is 2, aluminium is 2 here. So what my, like how I balance is, firstly I try to balance the element that is not oxygen or not, that is not hydrogen. That is, here it is 2, here it is 2. Now because it is balanced, now still I have an idea that this is 2, this is 2. Sulfur, if you see, sulfur is 3 there and here it is 1. So can I write 3 here? Now if I see oxygen is balanced or not, let's see if oxygen is balanced or not. Aluminium is 2, aluminium is 2, aluminium is 2 here, right? Sulfur is 3 here, sulfur is 3 here. 3 into S. Hydrogen will be what? If hydrogen and oxygen are balanced, then good to go. Hydrogen is 3 into 2, 6, right? Here hydrogen is not 6, here hydrogen is this. So I'll multiply this with hydrogen. So now also hydrogen will be 6. Now if oxygen is balanced, then that is great. Oxygen is 4 into 3, that is 12. Here oxygen is 4 into 3, that is 12. Can I say this reaction is balanced? Can I say this reaction is balanced, guys? Definitely this reaction is balanced. Okay, so firstly try to balance the atom that is not hydrogen or oxygen. Automatically you will see, you will start balancing a lot of reactions. This is highly useful in your stoichiometry. This we don't even, in here you consider it as a balancing. In class 11, that is not even a step. That means this we assume in class 11, nobody is going to teach you balancing, right? They will assume that you know this because you have already learned this. But if you don't know balancing, you will get stuck in the questions, right? That's why I have taken up this basic lecture for you, right? Okay, understood everybody? Yes, Sankar, Sanju, Abhijit. Yes, everybody. Beta, don't spam. Okay, now let's see this here. This is already done. Okay, right? Now this is for your homework, right? This is for your homework. Okay, what I'll give you for your homework is, do these 2 for your homework, these 3 for your homework. Okay, write down your balancing. This I am giving you for your homework. Okay, write down the balancing thing will be given in the homework. Now if you see this, this is BA, this is BA. BA is 1, 1, S is 3 here, S is 3. So I'll multiply this by 3. I'll multiply this also by 3. Can I see now? Barium is 3, barium is 3. Chlorine is what? Chlorine is 3, chlorine is 3, 2. So can I just multiply it by 2? Aluminium is 2, aluminium is 2. Barium is 3, barium is 3. Chlorine is 3 into 2, 6. Chlorine is 3 into 2, 6. Sulfur is 3, 3. Oxygen is 4 into 3, 12. Oxygen is 4 into 3, 12. That means this is already balanced. Okay, let's do this here. This is so very simple. It's already balanced. You don't even need to balance it. What about this one? Iron is Fe. Chalo, this I'll do. This I'll do. Okay, this I'll do. Iron is Fe. It is Fe. Chlorine is 3. So can I multiply this by 3? Or can I multiply this by 2? And I multiply this by 2. So now iron will become 2, iron will become 2. Chlorine will become 3 into 2, 6. Chlorine will become 3 into 2, 6. Done. Okay. So these are simple balancing of equation that you should know. Right? Okay. Right, everybody? Right, everybody? This we have done. Beta, what is the name of the channel? It's JEE. Right? And what we are doing? Basic foundations. Right? So neat previous year question, I think there is no use, right? So don't spam, right? Try to maintain the discipline in the class, right? Okay. Now, acid and bases, this you will study in ionic equilibrium. Okay, this you will study in ionic equilibrium. There is a chapter called equilibrium. We will study about acid, bases and all of that. Acids are which has pH less than, pH scale is less than 7, right? Acid is like you have vinegar, lemon juice, battery acid, soda. All these are acids which turns red, which turns blue litmus red, right? And they give H positive ions. And you know what? Acid, only this definition I am showing you right now. Different definitions of acid and bases you will study. What is the Lewis acid? What is the Lewis base? All of these you will study. Bronsted acid, Bronsted base, Arrhenius acid, Arrhenius base. This is all what you will study in the ionic equilibrium, right? But for that, you should know the basic definition of acid and bases. Basic definition is a substance of bases where OH negative ion in the egg, which release OH negative ion, and in this pH is greater than 7. That means it will be live from 7 to 14, right? And this you can study that if you talk about your battery acid, HCl, that is very like highly acidic in nature. Stomach acid is little bit diluted with 1 pH. Then you have lemon with 2, vinegar with 3, tomato with 4, coffee with 5, milk with 6. Milk is also acidic in nature. Those who think that milk is basic, no, it is acidic in nature, but very slightly acidic. 7 is the neutral, like you have water, right? And blood is a buffer, but it is slightly basic in nature. And 9 is baking soda that you use while making cakes and all, right? Stomach tablets, antacids that we use, that is having around 10 pH. Then ammonium solution, that is having around 11. Then soap is 12, bleach is 13, and cleaners, right, that is having 14 base, right? And it is, I don't know why one of my students, he asked me that, ma'am, base is good for body. No, the one which is very highly basic, that is not good. Our body can only digest, it's not like our body cannot digest acidic things, but acid also to a certain level, base also to a certain level, right? More than that, our body cannot digest. Okay. Now, last part is, let's talk about carbons, like organic chemistry. Full organic chemistry is based on which thing? Full organic chemistry is based on this one thing, that is carbon. Carbon, its compounds, that is all we talk about organic chemistry. And in organic chemistry, you will see you have so many chapters, like you have, first you have GOC, general organic chemistry, then you have isomerism, IUPAC naming, this and that, different functional groups you have. You have to study every single functional group. Now, I know that you have studied this in carbon and its compound. You have just studied the base of organic chemistry. What you have studied is why carbon forms so many compounds. That is the base of organic chemistry. Why carbon is forming so many compounds that we have to give it a different branch, that is called organic chemistry, because of its two properties. One is called catenation, its ability to form compounds with itself. You have one carbon, it is going to get connected with carbon, then with carbon, then with carbon, then with carbon. That's why it is forming large number of compounds and very large masses of compounds it is forming, right? And next property is tetravalency. It has 4 valencies here, that means 4 bonds it can form. What if it forms 4 bonds with carbon? Let's say I have a page here, it is this carbon 1 2 3 4, right? Again it is forming with carbon, again it is forming with carbon, again it is forming with carbon, again with carbon, again with carbon. Now it has decided to form with hydrogen, hydrogen, hydrogen. That is the termination. Now it has decided to form with nitrogen. Now it has decided to form with sulfur. Now it has decided to form with phosphorus, right? So carbon forms compounds like with carbon. That's why there are so many number of compounds, because there are so many different chains, right? So, and it also has tetravalency. That is the reason there are so many compounds of carbon. So you will see everything around us is carbon. Me, I am formed up of, you, we all are formed up, made up of carbon, right? We are made up of carbon, right? But ma'am, we are made up of atoms. Arey, carbon is an atom only, na? Right? So we are made up of which atom? Carbon atom, right? So that's why, like, you see, why on heating, like whenever you have any dead body, right? When it is heated, it is combustible. Why? Because it is formed up of carbon, right? So everything around us is formed up of carbon, right? Like your urea, that is also a, like, it also has a carbon compound there, right? Now, earlier what was thought that organic compounds, why it is called, firstly tell me ma'am, why it is, ma'am, it should be carbon compounds, ma'am, name should be carbon compounds, isn't it? Why the name is organic compounds? Organic, now whenever you talk about organic, you talk about natural, and that means all the organic compounds are natural? No. Then ma'am, why organic compounds are called organic compounds? That means natural compounds. See, earlier, na, scientists used to think that, I'm talking about like so many decades back, scientists used to think that, centuries back, I would say, they used to think that organic compounds, like we have urea, right, that is found in our urine, that is an organic compound. They used to think that all these organic compounds that you see in nature, some vital force like God is creating all of these compounds. We can't create these compounds in labs. That's why they named these compounds of carbon as organic compounds. But after that, there was a scientist called Wöhler. There was a scientist called Wöhler who made urea in the lab. Urea in the lab, right? So he made urea from an inorganic compound. What he did, he made urea, he took an inorganic compound, he made urea, which is an organic compound. And now we know that even organic compounds can be synthesized in the lab. Because organic compounds can be synthesized in the lab, we can't say that all the organic compounds are naturally occurring. No, they are naturally occurring, but we also can synthesize them in the lab. That is the history of organic compounds, right? That's why this organic branch further increased, because now we are able to synthesize them in the labs, right? Why there are so many polymers? The eraser that you are using, that is also polymer, right? Why? PVCs you see in the house, polyvinyl chloride, that you will see if you're preparing for JEE Advanced, you will study polymers. If you're preparing for JEE Mains, you will not study polymers, right? But PVC, polyvinyl chloride, right, that we use in our houses for decoration, right? What is all this? These are all organic compound polymers, right? So that is very important, very interesting thing to know, right? And this I have already told you why it is showing this, right? Now, beta, what all you are going to study, okay? So first thing is, this chapter is in class 11th. This chapter is in class 11th. That is hydrocarbon. That means only hydrogen and carbon. With only hydrogen and carbon, no other compound you have, no other atom you have here. You have alkane, you have alkene, you have alkyne. These are the three things. Alkane is having single bond. Ma'am, this is having double bond, this is having triple bond. Now you will see, ma'am, what is single bond, what is double bond, what is triple bond. Single bond, double bond, triple bond, you will study in inorganic chemistry, chemical bonds. Okay, what is single bond, double bond, triple bonds? But you will apply that in organic chemistry. So that's why chemical bonding is very important to understand organic chemistry, right? If you have not studied chemical bonding in detail, then organic chemistry core you won't be able to understand, right? So core of organic chemistry is chemical bonding chapter, and structure of atom you should know, electronic configuration, that will be used in organic chemistry, right? Now this was your this you will study in class 11, right? Full detail you will study, preparation, properties, so much detail you will study now that it's like you will just mix this in sub cup and you will just drink it. That detail of study that you will do, right? Now if you see this here, function group, alkane, alkene, alkyne, then arenes. What are arenes? When you have benzene, benzene you must have seen, this is called benzene, right? This is called benzene, right? What is benzene? What is aromatic compounds? What is halo? Halo is halogen, halogen. That is chlorine, bromine, iodine. These are the compounds, halogens. When you attach any uh, carbon and hydrogen compound, hydrocarbon with halogen, which is denoted by X, that is called haloalkane. If it is in the ring form, that is called haloarene. Aldehyde, ketone, alcohol, ether. This you have a chapter for aldehyde, ketones, and carboxylic acid, a separate chapter. For alcohol, ethers, and phenols, you have a different chapter. Amines, you have a different chapter. Acid anhydride, you will see the reactions within the chapter. Right? Ester will also be within the chapter only. It's not a different chapter. Amide, you will study in amines only. Acyl halide, you will also study in amines only. Right? So these we don't have a specific chapters to understand acid anhydride, ester, amide, or acyl chlorides. But you will study all of this in between these compounds, in between the reactions. But for these compounds, we have specific chapters, right? We will study this. Right? Then you will study about hydrocarbons, aromatic compounds, simple oxygen containing carbonyl compound. This is called carbonyl. C double bond O oxygen. Carbonyl compounds we are going to study like aldehyde, ketones, carboxylic acid, amide, acyl halide, ester. All these are carbonyl compounds, right? And acid anhydride, all these are carbonyl compounds. Then you have carboxylic acid derivatives. See, देखो बेटा, what are hydrocarbons? I'll just show that to you. What are hydrocarbons? When only hydrogen and carbon is there. What is an aromatic compound? Where you have benzene. What is a heteroatom? Heteroatom are like nitrogen, oxygen, not oxygen, nitrogen, sulfur, that is there. They are called heteroatom, like haloalkanes, haloarenes, amines, they are heteroatom. Now, if you talk about simple oxygen containing, ROH, ROR, these are oxygen, simple, there is no double bond, triple bond with the oxygen. When you talk about C double bond O, that is carbonyl. You have aldehyde ketones. These are carbonyl containing compounds. What is an acid? RCOH is an acid, carboxylic acid. When you replace OH with OCOR, that is called anhydride. When you replace OH with OR, that is called ester. OH replaced with NH2 is called amide. OH replaced with halogen is called acyl halide. Okay? So all these compounds we are going to study in full organic chemistry. Organic chemistry is all about, you will study in detail about these compounds, the preparation, properties, everything you are going to study. Okay? Clear everybody? Right? Yes, everybody? Clear now? Clear no? Let's do 2-3 questions based on this. Right? So first one is, identify the carbon compound which has carboxylic acid as the functional group. Carboxylic acid as a functional group. Can you see? What is carboxylic acid? COOH. So it is B is having carboxylic acid. So answer will be B is the correct answer. Okay. Ma'am, I am 12th going student. Sorry, you are just deleted. Okay. Now let us see who is going to answer this. Identify carbon compound which has halo compound as the functional group. Now, this is for your homework. This is for your homework. Let me see who is going to answer this. Beta, you also need to answer what is the name of this A, what is the name of this B, what is the name of this C, and what is the name of this D. Okay. Name of all, name of A, B, C, D functional groups. Okay, this is your homework, beta. You can just take the screenshot here for all the students who are serious, right? Even if you are JEE 2026, JEE 2027 aspirant, if you are genuinely serious, I want you guys to take the screenshot here, right? And answer me in the comment section. Okay, I'll also pick out your comments, right? I want to see your comments giving the answers, right? So that I can also see that, okay, the hard work that we are putting into, we are providing you the free knowledge that is also aligned somewhere. You're also serious about your studies. What I can do about it, I can give you the homework, right? And for that only I can get to know whether you're able to understand that or not, right? So take a screenshot here, and this is your homework. You're going to answer me the functional group for all of these. Okay? Yes, everybody? Okay? Yes, everybody? Yes, everybody? Yes. Chalo. That's it for today, students. Ma'am, I am 12 going students. My friends shifted to another batch. Someone told them won't teach. Thank you so much, Karthik. Thank you so much. Right? Huh. Which batch you are talking about? Which batch you are talking about? Acha. Now let us see this here. That is your QR scanner. Just scan this QR scanner here. This is your JEE English channel, Telegram channel here. In this Telegram channel, beta, you will get all the notifications of your live classes that we are going to take up on this channel, right? YouTube channel. But for that, you have to subscribe to the channel, right? And also the link is also in the description. And for all the students who are preparing for JEE 2027 or the repeater students, then guys, at this point, IB SAT scholarship is going on, right? To get, if you want to get enrolled to our offline centers, right? Because you can see our ranks here, right? If you want to be like here next year, right? Or next to next year for JEE 2027 aspirants, then what you need to do is, and you want to get a scholarship here, all you need to do is register yourself to IB SAT scholarship program where you can avail up to 90% scholarship. And for all the droppers, repeaters, we are providing you granted rank improvement, or else we'll refund your fees 100%, right? So if we are providing you that much thing, the promise is there, that means definitely you are going to get benefited out of the classes. And for your nearest Vedantu center, you can see here Tamil Nadu, Andhra Pradesh, Telangana, Punjab, Maharashtra, Delhi, Bihar, Odisha, Rajasthan, Pondicherry, Karnataka, Uttar Pradesh. The nearest centers you can see here, right? And I would advise you to go and visit the nearest center so that you can meet our counselors, right? If you have any doubt, you can just tell that I'm from Vedantu JEE English, right? You will be, the counseling you can have there, you can meet the teachers there, right? You can take the demo sessions there. So that will be very, very helpful for you to understand what is the direction, what is the path that you want to go in, right? So that's it for today, students. And I want all of you to comment down which thing, your homework, right, in the comments, your homework in the comments. And I have already given you the homework here. I've already given you the homework here. Again, I'm saying you can take the screenshot. You need to tell me A, B, C, D. What are the functional groups of A, B, C, D? Okay, right? Yes. And the next live plan, everything is already scheduled on the channel. You can go and check that out, right? Next, first thing is I'm going to take a lecture on unit and conversions, right? Because I know that in physical chemistry, students are confused and nobody takes up a detailed lecture on unit and conversion. I know that is needed because I have seen students, they know the formula, but they don't know the conversion. They don't know how to convert joule into electron volt, how to, there is a constant called Rydberg constant. Okay, these are the important things that we are going to talk about. Even decimeter, centimeter, picometer, nanometer, angstrom, all these things we are going to talk about in the unit and conversion lecture. And one lecture, if you want me to take up, I'll make one lecture on periodic table. That also you can let me know in the comment section. Okay, yes. Okay then students, bye-bye, take care, see you all. I'm waiting for your comments in the comment section. Till then, bye-bye, take care, see you. Bye-bye.